Our next keynote speaker is Dr. Catalina Cáceres. She holds a degree in surveying engineering and specializes in geodetic applications related to transformation between reference systems. She currently serves as coordinator of the SIRGAS-CON network analysis and has extensive experience in geodetic data analysis and reference frame processing. She is also part of the official SIRGAS Associated Processing Center, supporting GNSS data processing and regional geodetic initiative. Her presentation is entitled IGS and SIRGAS, 30+ years of GNSS geodesy in the Americas. Please welcome Dr. Cáceres.
Hello, everyone. My name is Catalina Cáceres. I am member of the Processing Center of USACH, and I am the Analysis Coordinator at the SIRGAS. I'm going to give a presentation on IGS and SIRGAS, 30+ years of GNSS geodesy and in the Americas. The presentation the presentation we cover the following topics: history and organization of SIRGAS, SIRGAS working group and its relationship with IGS, scientific processing and analysis, SIRGAS products, capacity building, University SIRGAS, future challenge and opportunities, and conclusions. SIRGAS represented the regional realization of the International Terrestrial Reference Frame for the Latin America and the Caribbean. It provides a consistent geocentric reference frame, supports development of a unified vertical datum, maintains a continental GNSS infrastructure, and generates a wide variety of scientific products. An important aspect of SIRGAS is that all activities are performed in accordance with IGS and IGS. A standard, this ensures compatibility between regional products and the global reference frames. To understand SIRGAS, it is useful to look back. SIRGAS was officially founded in 1993, the International Conference for the Definition of the South American Geocentric Reference System in Asunción, Paraguay. At that time, many countries in South America were still using classical local datum that were not compatible with modern satellite positional techniques. The initiative was supported by 3 organizations: the International Association of Geodesy, Pan American Institute of Geography and History, and National Geospatial Intelligence Agency of the USA. The common objective was to promote the adoption of a modern geocentric reference frame. One of the most notable aspects of the SIRGAS is its evolution over time. The first realization, SIRGAS 95, consisted of 58 GPS station distributed in South America. 5 years later, Sirgas 2000 expanded the network, incorporating 184 stations. However, the most important development was the creation of Sirgascon, moving from the periodic campaign to a continuously operation network. Before discussion, the technical aspect, it is useful to understand its organization structure of Sirgas. At the most high level, Sirgas operates under scientific frames of the IGS and APGH. The organization includes Directive Council, Scientific Committee, and Executive Committee, and the 3 working groups. About the first working group is responsibility for the operation and maintains Sirgas.com. The activities the working group included data acquisition, quality control, GNSS processing, solution combination, and products generation. The group currently consists of 13 data centers, 12 processing centers, 1 neutral atmospheric analysis center, and 1 subgroup, the real time. And this activity coordinated by the SHIR, the network coordinates, and the analysis coordinator. The main objective, the working group 1, is to ensure that continental reference frame and it remains stable and consistent over time. About CIMA, located in Mendoza, Argentina, and serves as the Sirgas Neutral Atmospheric Analysis Center. The mission is to generate regional tropospheric products derived for GNSS observation. About real time, one of the newest initiatives within Sirgas real-time subgroup. The objective is to explore the integration of the real-time GNSS data stream across the regional using entry technology. About Sirgascon, today the network includes about 475 cores. The station processed every week following a coordinated scientific strategy. Currently, network is analysis using GPS, GLONASS, and Galileo observation. The network is supported by hundreds of academic, governmental, and research organizations. Currently, about 274 institutions that contribution to the network. Another important aspect of Sirgascon is its continuously technology evolution. All stations tracked GPS constellation, but however, we have observed a significant increase in the number of stations capable of tracking GLONASS, Galileo, Beidou, and others. While Working Group 1 focuses on the continental reference frame, Working Group 2 focuses on implementation and national levels. His activity includes supporting the integration of national network into international terrestrial reference frames and healthy member. The working group 3 focuses on vertical reference system, and working group 3 coordinates activity related to gravity network, leveling network, and geoid determination and geopotential models. The objective is the development and maintenance of a unified vertical reference system for the Americas. Respect CIRGAS and IGS. The relationship between CIRGAS and IGS has existed for decades and extended far beyond that sharings. Both organizations share a common objective to maintain and globally consistent terrestrial reference frames, while ensuring regional densification. This collaboration involves standard, infrastructure, and scientific products. IGS provides the global frames upon which CIRGAS is built. This includes preset orbits, clocks product, station coordinates, antenna calibration, and international standard. Every week, the processing center of CIRGAS uses the product and for the processing. However, relationship isn't unidirectional. CIRGAS contributed to IDS with geodetic infrastructure, scientific products, and tropospheric products. For the weekly processing, CIRGAS have a 12 processing center. Although different software packages are used, but all centers allow a common set of a standard and convention. One of the strengths of the CIRGAS processing strategy is the redundancy. Multiple independent centers analyzing a developing station set, allowing cross-validation and quality control. Additional, CIRGAS has 2 combination centers that generate the official weekly solution. And the station is as processing for 3 centers. The workflow shows a step to follow a calculation weekly solution. The regional data center distributed the observation data and the analysis center. For the processing, allow some analysis center use Bernes and other use gamut globe. But the observation model is harmonized. The reference product is harmonized. The convention is harmonized and metadata is harmonized. Above the quality control, workflow illustrates the sequences of check performance before solution becomes part of the CIRGAS product. First step, verify observation data, evaluate for components and consistency. The analysis center verify coordinate behavior and processing statistic. And combination center verify a statistic of the combination solution. Starting with GNSS observation, CIRGAS performs scientific processing and quality control to generate several classes of products. These are weekly solution, multi-year solution, velocity models, deformation models, Adela within CIRGAS, and tropospheric products. Respect to the capacity building, CIRGAS has always considered capacity building to be a fundamental component of the mission. through a school, workshop, technical courses, and scientific meeting. This activity facilitates knowledge transfer, stretch regional cooperation, and help members country. In the last 5 years, we have had 13 events. Respect to future challenge and opportunity. The first challenge is the transition from static reference frames of dynamic reference frames, respect to the national reference frames member of CIRCAS. Because of the tectonic activity, earthquake, and nonlinear displacement in the regions. And the second change is the implementation of the international high reference frame. So the regions, this requires the harmonization of national vertical datum. But challenges which require a strong scientific collaboration and sustained international cooperation. In conclusion, CIRGAS establishes itself a robust continental reference frame for the Americas. Collaboration with the IGS included scientific products, technicals, and operation areas. CIRGAS has evolved over time, moving for a GPS campaign in its early days to continued geodetic reference frames and infrastructure today. The future requires a dynamic reference frame for member countries, as well as a unified vertical datum in line with EID recommendation. The CIRGAS generate wide range of products that support processing, geodynamic, and atmospheric science for the reference frame. Thank you for your attention.